Hello all, welcome to VZD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to teach one more basic gate called AND gate. Sir, we have seen in the previous lecture about NOT gate and its entire properties and its truth table, logical expression and circuit diagram, and also we have seen its transistor circuit diagram. Now let me try to explain AND gate and its entire characteristics, or we can also say what is the truth table and how to understand its associative law, commutative law we need to see. Sir, the moment when I say AND gate, AND gate, sir, this is a basic gate, we can say basic gate. Here, when I look into AND gate or any logic gate, the moment when I start to understand, sir, the things we must be able to understand is, first, what is its logic circuit? What is its logic circuit? We just need to understand. And second thing is, we must know about what is its truth table. What is its truth table? We must know. And third one is how many number of inputs and we can say outputs. And now the fourth one, we must be able to understand what is its logical expression. What is its logical expression? And fifth one, we can say what is the control input. Control input for 0. And now what is the control input? Control input for 1. And we must be able to understand what is commutative law. What is commutative law? And what is associative law? Associative law. And finally, we must understand what is meant by unused input. Unused input. Sir, these are the things we must be able to understand whenever we are studying about any logic gate. Let me start here. Sir, what is the logic circuit for AND gate? We know that the first thing is logic circuit for AND gate. Here, I can say this is the logic circuit. Now, these are the inputs A and B. Sir, this is output Y equal to A into B. Simply we can say this is a circuit which is performing multiplication operation. And now the second one is truth table, sir. The moment when we are drawing a truth table, we must be able to understand how many number of inputs here. Here two inputs, here A and B, we can say n equal to 2. To calculate for two inputs how many number of input combinations we are getting, because here we have 2 power n equation, we can say 2 square, total we have 4 combinations. Sir, truth table when I am drawing, sir, here inputs are A and B, and now Y equal to A into B is the logical expression, we can say output. Here 4 combinations we have available. One is 0, 0, 0, 1, and now 1, 0, and finally 1, 1. Sir, these are the 4 input combinations. For these 4 input combinations, let us try to understand truth table. Here, the first input is A equal to 0 and B equal to 0. When we apply A equal to 0 and B equal to 0, here the logic gate performing multiplication operation 0 into 0, automatically Y equal to A into B, or we can say 0 into 0, output we can say 0 into 0, output will become 0. And now the second input, here A equal to 0 and then B equal to 1 we can say. The moment when we apply A into 0 and B equal to 1, automatically this will become multiplication operation, sir. Again 0 into 1 will become a 0. And now third one we can say here A equal to 1, sir, and B equal to 0. So automatically 1 into 0, again multiplication operation, we can say 0. And finally, when we apply A equal to 1 and B equal to 1, automatically this will be the multiplication operation, Y equal to 1 into 1, and now output will be 1. So this is the truth table of AND gate. In other way, we can understand this truth table. The moment whenever one of the input is 0, automatically output is 0. I can say this logic to understand or to remember easy. Sir, here let us try to understand. Here b equal to 0. Of course both inputs are 0. Here if one of the inputs is 0, automatically output is 0. Here a equal to 0. Here one of the inputs is 0, automatically output is 0. And here also third case, if one of the input is 0, output is automatically 0. The moment when we are applying both the inputs are high, then only output is high for the AND gate case. Sir, we just need to remember this logic. Now let us see third one. Here we can say number of inputs and then output. From the logic circuit we can say number of inputs are, we can say 2, and now outputs are, we can say 1. And now the fourth thing is we can say logical expression. Sir, we have seen already at the output end. Here logical expression is y equal to a into b, we can say. This is what logical expression, or otherwise I can write here y equal to a into b. Sir, this is what logical expression. Now let us try to understand the fifth point, control input 0. Sir, what is control input 0? Fifth point, control input is 0. Sir, what is the meaning of control input 0? Let me take one AND gate here. Sir, this is AND gate. What I am trying to do here is, here a equal to one of the input and this is another input b. I can say I want to keep this b always 0. I want to keep this b always 0. We can say this is control input. I want to keep it as always 0. And now this is output y equal to a into b. We know that. Sir, let us try to understand. Here the moment when I keep on putting this b equal to 0, and now I want to change the inputs here. A equal to, I want to apply 1 as the first case, and I want to apply as second case 0. And now let me take third case as x, and now let me take fourth case as, let me take any square wave. Sir, here I want to take different inputs here, a and then b as, I want to keep it as 0. Let me try to understand how the circuit will act as. Sir, the moment when I say a equal to 1 and now b equal to 0, how the circuit can act as? We know that, sir, here we know that the moment when we apply a equal to 0 and then here a equal to 1 and then b equal to 0, we can say third case, sir, automatically output is 0. Here output is, first case output is 0, we can say. And now second case, here a equal to 0 I want to take, and then b I want to keep it as a 0. Sir, for a equal to 0 and b equal to 0, which means we can say from truth table, this is what first case. When we are giving a equal to 0, b equal to 0, automatically output will be again 0. And now third case I want to say, here b is constantly 0, and now third case here we can say a equal to x. Sir, I told you already in the same lecture, if one of the input is 0, for the AND gate, output is always 0. Here b is 0 because it is a multiplication operation. Whether we can take a equal to 1, 0, x or somebody else or whatever we take, automatically output is 0. And the same case will be applied for the fourth input a equal to, if you can take any square wave also, output will be square wave into 0, output we can say 0. Sir, after applying these four types of inputs as to a, and when we keep b equal to 0, what we are getting, sir, we are keep on getting output as 0. We can say this is what 0 means, a disable. So when we are keep on applying b equal to one of the input is 0, here we are getting our fixed output, or we can say this circuit we can say that control input or disable input. disable input, we can say that, because here b equal to 0, when we keep on applying b equal to 0, the circuit is acting as producing as disable output or fixed output, sir. And now let me consider the sixth case even. Sixth case, control input equal to 1. Let me take this condition. How the circuit will act is, let me try to understand. Sir, here let me take one more time, AND gate, this is A, and now we can say this is B. Here b equal to 1 I want to put, and now here a equal to first thing 1, 0, and let me take x, and now fourth case let me take any square wave. Here output y equal to a into b. This is what. Now sir, let me analyze the circuit. Here a equal to 1 and then b equal to 1, the first case. Here a equal to 1 and then b equal to 1. We know sir that from the truth table, when we are applying both the inputs are 1, then we are getting output as 1 for the first case. And now second case, here a equal to, second case here a equal to 0. So I want to change the input of a. Here a equal to 0 and b equal to 1. We can say that this is what the second case. Here a equal to 0, b equal to 1. We can say output is 0. And now third case, here a equal to x, we can say a equal to x. The moment I can take a equal to x and b equal to 1, we can say that multiplication 1 into x, we can say x. Sir, instead of multiplication, I want to tell you one logic to remember here. Sir, for the gate point of view or any competitive exam point of view, sir, for the AND gate, I told you already, whenever one of the input is 0, output is always 0. And now I want to tell one logic here. If one of the input is 1, if one of the inputs is 1, then the output is another input. Sir, let me tell you again. The moment when we consider AND gate, if one of the input is 0, output is always 0, I told you. Sir, if one of the input is 1, if one of the inputs 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 is 1, the output is automatically another input. The output is automatically another input. The output is automatically another input. Based upon this logic, we can say that here a equal to x and b equal to 1. So based upon this, if one of the inputs is 1, so output we can say x. And now here also, here the fourth case, square wave we took as an input, a equal to square wave, and one of the inputs is 1. So output we may say that output must be square wave. Sir, in the control input, when we are keep on applying b equal to 1, what we are getting is, here we are just getting the same input a, which means here the circuit acting as a buffer. Sir, I can say that the circuit is acting as a buffer, and then we can also call as, here we can say circuit can act as a memory element. After we are applying a equal to 10x square wave, after some delay, we can say 1 nanosecond or 2 nanosecond, whatever the delay based upon the condition, and now based upon the gate. Now, but after some delay, the gate is producing the same input what we are applying at A. So I can say that this is what? A memory element. Memory circuit or memory element. It is acting as a memory element when we are applying one of the input is 1. So for the AND gate. Now let me take the seventh case, sir. Here commutative law. What is commutative law? This is what very important case we just need to understand, sir. What is commutative law? The moment when I interchange the inputs, here this is a logic circuit A and B. Now this is y equal to A into B. Sir, suppose if I can interchange, instead of A, if I can take here B, instead of B, if I can take A, what the circuit behaves, how the circuit behaves, sir. Here let us try to understand. This is a circuit. Here one of the input is B. Instead of A, I am taking here B, and now here I want to apply A. Sir, y equal to B into A, I want to take. These are the two different circuits which are producing the same output, which means if I can interchange the values, input values, the output is same, then the circuit is acting as or satisfying commutative law. Based upon truth table, let me try to understand. Here A, B, and now y equal to A into B. Here y equal to B into A. Sir, we have four combinations: 0, 0, 0, 1, 0, 1, 1, 0, and now 1, 1. Here these are the four combinations. Here 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. Here also B into A, which means 0 into 0, 0, 1 into 0, 0, and now 0 into 1, 0, 1 into 1, 1. Here for four combinations, output is same. So the circuit is satisfying commutative law. Based upon this truth table, we can understand that the circuit is satisfying commutative law. And now here we can take one more input extra. We can say the circuit is satisfying associative law also. Sir, let me take here 8th one as associative law. We can say associative law. What is the associative law means? Here these are the two inputs A and B. I want to call this output of A and B is Y1. And now let me take another input, we can say C, and now I want to connect these two inputs to one more AND gate. I can say this is what? Y2. Sir, another condition is suppose if I can interchange the inputs, sir. Suppose if I can interchange the inputs here, let me draw like this. This is Y1 and this is Y2. Suppose if I can interchange the outputs, this is B and this is C. Here I can say Y1. And now third input A. I want to connect one more AND gate. Here this is Y2. Sir, I want to call this, here the output is A into B and into C equal to here B into C into A. These two conditions are same, so that this output is, or we can say this output is satisfying associative law. We can understand more about this logic circuit, logical expression based upon truth table. We can take A into B and now we can multiply the output of A into B with C. So now we will get one expression, and now B into C multiplication with A, almost we can get same output. Based upon this knowledge, we can say that, sir, this circuit is following associative law. Sir, after completion of 8th point, we have left over with one more point, that is called unused input. Here we have one unused input condition. Let us try to understand what is unused input. Sir, 9th point, we have unused input. Unused input, which means the moment when I consider AND gate here, this is AND gate. We can say this is a two input AND gate, A and B. Output we know that Y equal to A into B. Sir, suppose if I can connect one more input here, if I can connect that extra input to plus VCC, which means collector control voltage, even then this particular circuit will work. So this is what unused input. We can connect unused input to either power supply, even then the circuit can work. This is what case 1. And now case 2, let me take. Suppose if I can connect this unused input, I can say A and here this is B. If I can connect this third input to one of the inputs here, we have two inputs A and B. Suppose if I can connect third input to B, Here this circuit can works y equal to a into b. And now similarly we can interchange. Here this is a and now this is b. I can connect third input to even a. Of course this circuit can works y equal to a into b. And now third case, sir, here let us try to understand. Sir, here we can connect the third input to even. Here first one is a, second one is b. We can connect third input to 1. Here y equal to a into b. Sir, based upon the condition, suppose if I am using here this particular logic gate is TTL, which means transistor logic family, then we can connect this extra input, or we can say floating input to 1, no problem. Suppose if we can connect, which means TTL means 1, we need to connect. Suppose if we are connecting ECL, emitter coupled logic family gate, if we are using, we just need to connect here as 0. Based upon the gate or logic family which we are using, the better connection for the AND gate to use, or the better connection for the AND gate to connect the extra input or third input is always we can say 1. So for 1 we can say we must use TTL gate. So this is the best logic for the AND gate to connect. So this is what about AND gate, sir. Now let us try to understand one more gate called OR gate. Thanks for watching. Please do subscribe.